Hello everyone and welcome to the first part series of making LED panel. So if you saw my channel a long time ago, I'm interested in making quite silly stupid things, and in the end some of the things are reasonable to even make it, some of them are not. So if you see my following list on the left, the subscribers, I'm following it. As you can see, I'm into the technology, into the CNC, into comedy, into the bass, into the random stuff, into the cars, and into the gaming, as you can see. And in the end, I can do half of that in good quality. As you can see, even trying a different color UV solder mask is not perfect from my side. But what I'm gonna do is I'm not gonna create any guitar, I'm not gonna play the piano. I'm probably gonna do something with an LEDs. If you saw from previous 3 years ago, the previous video, I tried to make my all solder mask and it kind of failed and it kind of not, and it was still working. But the problem is, what I'm trying to do right now is I'm trying to create my own LED panel from individual SMD LEDs rather than using one of these. I know you can say that, go and buy one of these flexible, not flexible display boards. And yes, they are not that really expensive, 30 bucks, but including the shipment, it's gonna be around 35 or 40 depending where you live. Also, you can buy in hardware store, but in the end it's 16 by 16, and from the size is not that small, right? And what I'm trying to do is trying to make like SMD type. So these ones are a bit bigger, 8 by 32, but the price is, as you can see, 2 or 3 times even bigger, and even worse depending from where you're buying. But in the end, what I'm trying to achieve, if you read the title and still staying till this moment, I'm trying to make something like that. Yes, like commercial type of LED displays. But the thing is, differences are between one of these and one of these are the LEDs, right? In one of this is addressable. So it's RGB, it's red, green, blue, blue, it's red, green, blue, and it has all these three colors, and I'm gonna show you under the microscope later. It has the integrated circuitry to control these three LEDs and mixed colors. And these panels right now, they are RGB, but they don't have any circuitry inside of it. Everything is on the outside. So what I will be doing is like a combination of both of this and this in order to achieve what I always wanted, to create my own PCB from scratch. And I think it might be interesting to watch it because, from previous videos, I do have some sort of experience, and if you don't have it, don't worry, we're gonna learn on the way. It's like first part, it's gonna suck, it's gonna fail terribly, but we're gonna continue until we're gonna find something best to make out of it. And looking at SMD components, we can find it really cheaply from eBay, AliExpress, or different websites. And if we're gonna buy in bulk, like look, it's 100 SMD LED diodes, and I think these ones are not RGB, but for 100 pieces it's like 27 cents. And for RGB, probably it's more. We can buy like colorized through hole components, we can buy as strips, but I'm not gonna use WS, which was it, I think these ones, right? I'm not gonna use one of these because the biggest disadvantage is you have to inject 5 volts at, I think, 5 meters, at the end of the 5 meters, or at every 2.5 meters, if I remember correctly. I can't remember exactly, but the problem is if you got power 5 meters of this LED strip and not inject to the end from your power supply, it's gonna lose some contrast and some colors at the end. So that's why it sucks. And as you can see, we have different type of LED strips from 32 meter, 60 or 144. And as you can see, the bigger the number of LEDs, the more power they're gonna use it. That's biggest disadvantage. And they work in 5 volts. That's what is terrible about these LEDs. And I really hate that they do not serve 12 volt LEDs. Well, the FS or WS2811 is 12 volts, but the chipset is on the outside. And the problem with the spacing, you can have smaller spacing because the chip is really close to RGB LED. Well, they could do on the other side, but it's gonna be more in the thickness, so it's gonna be way thicker than the strip right now. So for small projects it's good, but you have to inject them. The biggest disadvantage why I really don't like these strips is you have to use a lot of copper, a lot of wires if you're doing a big project like display screen or something, and it requires a lot of power from your 5 volt let's call it transformer, but it's gonna be just a switch mode power supply unit. But you can imagine that sometimes you need 5 volts and 100 amps to produce half of kilowatt, right? And it's gonna cost a lot in terms of electricity. Well, it's gonna cost a lot in electricity, but it's gonna cost in the copper and manufacturing, in the price, in everything. I mean, it's not usable for just makers, or I mean, it's gonna be way harder to make something like that. I mean, even with Arduino, you can have problems. If it's gonna be short string, it's good for decorations and something like that. But for the screens, well, we have to go for something like that. Otherwise, it's not even worth it. So for the first part, we're definitely gonna play around with these modules. And the biggest problem is, what should we be using, right? It's not gonna be 2 millimeters in a pixel pitch or size. We're definitely gonna be using like 64 by 32 dots or 32 by 16, and SMD size is gonna be like 20-ish something. And yeah, configuration, 1 red, 1 green, 1 blue. And the power consumption is gonna be way smaller, and input voltage, it's gonna be, at least I will try to find a chipset to work with 12 volts, but the problem is if we're gonna work with higher voltages, we're gonna use current limiting resistors, and it defeats the purpose of using the contrast. We can mix the color but at the maximum brightness. So for the first ever made LED screen in this channel, we're gonna use so-called shift registers and probably 1 color LED or strips, or I don't know, just through-hole components. And we're gonna definitely start ordering some components from DigiKey or the Mouser. And if you don't have any knowledge about electronics, I highly suggest some of the YouTube, I think it was, I can't find it right now, but I think you can find TechLink, oh no, it's for Linus Tech Tips, Marker Apps, I think even different YouTubers. I mean, you can just type in the search bar how to understand electronics. There's a bunch of videos out there, and all you need to know is what each component means. And most of the time, all you need to know is what the hell is the capacitor, the diode, the transistor, the resistor, fuse, how it looks like, and how to use it. But in this case, we're going to use integrated circuitry, which looks like this. And you can imagine that this integrated circuitry has a bunch of transistors, sometimes thousands or even millions, has a lot of capacitors or resistors inside of this component. Yes, believe me, it has all of these. And all that stuff is going to be used by this integrated circuitry rather than using a bunch of transistors. And there's not any MOSFETs here, but I think you got the idea. If you want to start working with projects like this, you definitely need to know at least the basics of the electronics, and we're definitely gonna use lower voltages. So we're not gonna use alternating current. We're gonna use direct current most of the time. So for the signal, it's gonna be digital if it's possible, at least for right now, for the safety and everything. But higher voltages are not recommended, and we're never gonna use it, at least in this channel if it's possible. If not, we're gonna use something else. But the power supply units tend to use alternating current and spits out direct current, so we're definitely gonna play with alternating and direct current, but I probably never gonna create, if it's possible, without, well, knowledge and everything, I'm not gonna create any power switching device with alternating current, because, well, one wrong mistake and you can have a huge disaster. So we're gonna be playing with alternating current, which is already made by high quality manufacturers like Meanwell, and we're gonna use that. That's it. Most of the time, this is what I'm doing, because I'm terrible of constructing my own power supply units. I made a couple of these, but in the end, probably gonna use the transformer just to step down, but has a lot of losses. But what I'm talking about is we're gonna make, well, LED screens. So sorry for keeping talking about that, but well, it's my first video after so much time. Well, after 1 years, years, I don't know. So we're definitely gonna use one of these. Okay, so let's get back to DigiKey, and I don't want to hold you that long for the first part series. So integrated circuits, networking solutions, we have a bunch of categories. So I'm definitely gonna go with integrated circuits and expand it. Well, you can do everything in the browser. This one's, for some reason, it's easier to look at it. And as you can see, some of the things I can guarantee, I don't know a bunch of the things from the electronics, and I'm learning as I go. So I think if you don't have any experience, at least learn the basics. There is plenty of videos, and we can continue with this, well, long journey tutorial. So we have logic, memory, power management. We don't care about that. We care about interface right now. So we're gonna open interface, and we're gonna find more and more. And we have some codecs, direct signal synthesis, modems, and some of them I do know, some of them I don't, but in the end, all we need is the drivers or controllers. So if I go for the drivers and controllers, this is the difference. This is the controllers. And some of the controllers are for USB, I2C, CAN buses, and these ones will be used maybe in the future, one-wire connectivity like serial and so on. But in the end, we're gonna use definitely I2C probably, or CAN bus, I don't know, but maybe I2C, maybe USB. But controllers are out of the question for now, and we're gonna go for the drivers. And this is the drivers. Transceiver, okay, what the hell is this? I have no idea also. But all we need to know is what kind of the type the driver is and what kind of the protocol it's gonna be. I'm not gonna select all of this. We definitely need an LED driver. As you can see, we can duplex with the current and everything. It's gonna be analog and so on and so on. If I select it correctly, we can find it here. If not, sometimes it's easier just to write information here. If I, for example, select it incorrectly, or I need more filtering, or I'm in wrong category, sometimes it's just easier to write LED driver. That's it. And as you can see, we have a bunch of LED drivers. It's just easy as that. And we definitely have in controllers, but just explanation, if you made a mistake or just in the wrong category, you can just find a better place. So we have display drivers, which is for display, and LED drivers. We're right now not displaying any display. I think it's like communicating via SPI or VGA, or I don't know, display port. I have no clue what I'm saying right now, but I'm gonna go for LED drivers. And having LED drivers, it's automatically saying that we're gonna have a bunch of these components, right? And I do know a couple of these, and the first ones I don't. Maybe it's the smaller ones, even some pictures have it, footprints and everything. But all I need to do is to find okay, what I'm trying to search right now, it's gonna be right, dimming. Okay, so we have selection frequencies. Well, we definitely want to go with higher frequencies and output voltages. As you can see, we have different output voltages, but I want to go for the number of outputs. So as you can see, we have a bunch of number of outputs and terminal switching, flyback. No. I think we need to go for what we should be going for. Shift registers, capacitors. I have no idea because AC/DC converter, it's nothing what I expected to be, but different manufacturers. I think package size is SMT. This is the how many number of the pins it has it. I think we have to go for like 36 or 64 if you want to go for something bigger. I mean, at least for now, I'm not gonna waste anyone's time, but in reality, what I should do right now is select the voltages, the number of outputs. So for example, 8, 16. Let's find the 16 right now, okay? And right now we should be having a bunch of components with 16 pins or 16 outputs. And as you can see, we have a bunch of SMD components or through-hole components depending on your situation and voltage supply minimum or maximum. I'm gonna go for SMD type because, well, through-hole components is not hard for me, but I want to make SMD PCB and solder everything on one side, and on the other side it's gonna be LEDs. That's why I have to go for SMD, because if it's gonna be through-hole components, I have to make a sandwich of different PCBs and so on, so it's just a waste of time. So I'm gonna go with SMD, but keep in mind these SMDs will not require hot air station to solder it, just the good tactics and soldering iron. That's my deal right now. So we have MIC, PCI, we have TLC. I do know TLC. I used Max or TLC back in the day, and I think it was LM, if I do remember correctly. So right now, let's see TLC. This is like linear. Let's go with 35 milliamps. So we have 50, 35, and the price, as you can see, it's not that expensive. It's like, if we want to buy like at least 10 of these pieces, it's going to be like 14 bucks. So it's not expensive. And as you can see, the power supply is voltage output 17 volts, 5.53 volts. And I think it's like shift register. Yes, it's a shift register. Register, sorry for saying that, is like shifting bits. That's it. And we're definitely gonna play with these components in the future, and I think I already played it like 10 or 15 years ago. And yeah, we're gonna go with this component, and we're gonna open a data sheet. Always keep in mind with electronics is, if it has a data sheet, read it or try to understand it. And the frequency is 35 megahertz, which is plenty enough for most of our applications right now. And number of output 16, so it's gonna be like 10 LEDs or something. Minimum voltage is 3 volts, it can be 3.3 and 5 volts, so easy as that. And opening the data sheet, this is what we can find inside of it, of that data sheet. Sorry for a long loading screen. And this is what we have. So we have a controller, we have a bunch of LEDs, and I know if you first time opening an data sheet of any electronic component, keep in mind there's not really that hard to read it. At least some of this information is going to be easy to read it, sometimes it's not. There's a bunch of videos out there how to understand it. Believe me, I don't know half of the data sheets how to read. I mean, at least in this data sheet, I don't know half of that stuff, but I know some of this stuff. So technically speaking, all we care is what kind of the conditions is required to power this device, and at least to know the symbol. So this is like a bulk image of this controller or this IC, and we have data, signal clock, latch pin, blank, and error read. This is the first time seeing the error pin. Oh, it's like a feedback, right? So it's good to know that we have additional LED driver with feedback control system. So if it gets wrong bit or something, it can fix itself or just make sure that never happens, or just put some information out there. So we have like from 0 to 15. So if we account it, we have 16 outputs. So it's more than 16 pins. So it's gonna be, I don't know, like 24. I don't know. So we can power more than one LED, but the thing is, the problem is we can connect in parallel. I mean in series, so it's gonna be series of LEDs in the same or different color, so we can power more LEDs, but I think we can power one LED, doesn't matter, but it just gives more voltage for one or more LEDs, which is nice. And 17 volts, it means like if one LED is like 3 volts, so we can connect like 5 LEDs in series. So 3 multiplied by 5 equals 15, and if we multiply by 6, it's going to be 18, too much, and it's not going to bright. It's not going to be very bright. And because it requires data signal and latch pins, we can probably even do without any controller. It's easy as that because it's shift register. We can shift bits, and it's not very complicated at all, but it's easier just to use any, I don't know, Arduino or SM controller. We're definitely going to use that. And what we care is the voltages, input range, output range, temperatures, speeds, current consumptions, and the speed, as you can see, it's nanoseconds. I mean, I'm not gonna even bother with that speeds, but you can see it 10 nanoseconds. I mean, your Arduino sometimes by default library like digital write even doesn't have that speed. You have to just modify the timers in order to get that speeds from your digital output. So we probably, in simple terms, will not reach that speeds, but in the future we might even go for that if we want to get higher speeds or refresh rates. And as you can see, temperatures, blah blah blah, microamps, how much of the consumption, some formulas, that's good. We have some formulas for deviation, load regulation, and so on. And some of the formulas, it's complicated to understand it, but sometimes it's easy to find it information on the internet, block system. But most of the time, all we care is what kind of the package, how it looks. And this is QFN package, and this one is a bit harder to solder because sometimes some of the solder pins are beneath the component itself, but some of them are still sticking out, so it's still not very hard to solder with soldering iron. But most of the time, if I have a component like that, I use hot air gun, and if I like this, I use soldering iron. And a lot of pins, not really hard, some different schematics for testing purposes, timing diagrams, and so on and so on. And I think we should be having some information or dimensions for the footprint, or I already missed it. No, should be some dimensions, right? We have some dimensions for the chipset itself, how it's gonna look, if it in this package or this package. I think it was the bottom. I think that this one is for stencils and soldering, but we're definitely gonna use one of these. And the pitch or distance between each pin, and if you can find some of the pinout on your PCB software, it's not going to be hard to implement one of these components. Even sometimes the biggest mistake is how I'm certain to use in my schematics, right? For example, this device doesn't exist in my library, but if you know the package name or type, pin number, length, width, height, and I don't know what the hell does it mean, but most of the time, if you have the drawing like this, you can make your own footprints and assign to each pin, because each pin, well, we definitely know what it means. I think it was here. Where was it? It was a table of the pinout. I think it was here, maybe. Sorry. Yes, we have a pinout, right? This is the pinout. This is the numbers, but in reality, the pinout has to be, I think, here. Maybe I made a mistake. Where's the pinout? This one doesn't have it, or no, this one has it, right? From 1 to 18, but some of the, I think I'm mistaking something. It should be the pinout. Where's the pinout? Or I'm mistaking with something. Well, in any case, oh yeah, right, I found it. I'm just sometimes blind. So this is the pinout. So If you have a component similar to this and some of the pins doesn't work out, you can copy the library or library's script of similar package and make a duplicate, like a copy of it, and modify it to your needs if it has the same distance. And I had this problem like 10 years ago when I needed to do something with KiCad or Eagle when it was free of charge and wasn't Autodesk software. But in any case, we're gonna use the tools which are available today, easy to use, easy to understand, and probably one of these components may be used in the future videos. So for the next part, I'm gonna probably demonstrate the shift register components, LED strip, SMD components, or whatever components do most of the time we have on our hand, easy to access. Don't need to order because it's possible to find it anywhere, and we're gonna tweak or play with these components before we can start working on a bigger project, which is LED screen, definitely. So thank everyone for watching, and we gonna see us on the next episode. See ya. Thank you for watching.